Hey everyone, welcome to pyrevise. Now we are going to discuss about lambda, map, filter, reduce functions. Then we'll talk about magic methods and operator overloading. So let's start with lambda. So why you need lambda or when you need lambda. Let's say you have some small work which has to be done in one line and you don't want to write a definition for it, the whole function syntax for it. That for that small work which you want for short period of time, use lambda function. Lambda has a simple syntax. Use lambda keyword, arguments, colon, and expression. Lambda can have any number of arguments and it only returns expression. There is no return value there. It returns whatever expression you write. Let's see in an example. We define a lambda function for multiplication of two values. X and y are arguments here, and expression x multiplied by y, that's what we return. We assign it to variable g2 of 3. As it an anonymous function, it doesn't has a function name, so you have to assign it to a variable and pass it to values to variable g2 of 3. You get output 6. Same way you can have lambda as a return statement in your function. Okay, so here a multiplier function which multiplies two values same, and we use lambda as a return statement. Now we assign multiplier to a variable g4, that is n, we have 4, and then we pass 6 to the g variable, we get 24. Same way you can call multiplier function with two values, 20 into 5, 20 is our n, 100 is multiplication. That's how you can use lambda. So many says lambda is tricky. There's nothing, it's simple. There is arguments and there is expression. You have to use that argument in expression, and that's the whole expression gets returned. That's how lambda works. Lambda is used in map, filter, reduce function in so many places. Mostly is used along with map, filter, and reduce. We will see map. So if you have an iterable or a sequence, let's say for sake of simplicity, list. If you have a list and you want to perform operation on each member of a list, then use map function. Map syntax is simple. Map, pass the function. So here you generally use lambda function and then your iterable or sequence or your list. So in map, lambda function, comma, list, and it will work on each. Lambda function will be applied on each item in a list. So we'll see. So we have defined the square list. What we want to do is we want square of each element in the list. We are taking a list from 1 to 10. So in general syntax, we will do it like this. We'll take a for loop, iterate over a list from 1 to 10 using our X range. You can use anything, and we append it to square. So what we get? We get our squares list, number square from 1 to 10. We can achieve the same thing using map this way. Map, then function lambda, which squares each number and pass the list here. We get our squares list. So this way map achieve squaring of numbers for us. This is simplified in a single line. Map can work with two lists as well. So we have two lists with same length. So now we want to multiply each atom in the same index position with each other. We pass this both to the map function. Lambda multiplies both the elements. We pass both the list, okay, to the iterable sequence. We get the multiplication. Only thing we have to keep in mind as both the list we are passing to a map function should have same length. Now filter function. So what does map do? Map acts on each member. Now what does filter do? As the name suggests, if you want to filter out some elements from a list, okay, depending on a condition, you use filter function. Say filter syntax is same, only filter function and pass your iterable or sequence. Now we are taking the same list. What we are doing is from numbers 1 to 10, we want the numbers which are divisible by, perfectly divisible by 2. We pass it to a filter function. Lambda does the expression or function for us, and then pass the sequence to it. We get 2, 4, 6, 8, 10. So in putting in general syntax, how filter works. So let's say we have tennis balls, okay, with different sizes ranging from 5 to 15, 5, 6, 10, and different sizes tennis ball there are in a basket. Now we are having a funnel. So we want to filter out the balls which are smaller than size in 10. So funnel, gauge size is 10. So whoever passes through this will get them. So that's how filter works. Whoever passes through the function, we get those filtered out, others are thrown out. This is how filter works. This is in general syntax in putting it. Now we'll talk about reduce. So reduce, what reduce does is, it reduces the whole list into a single value, depending on what expression you do. So now what we are doing is, so this is a syntax for reduce function, iterable same way. Now what we are doing is, we are taking the same list from 1 to 10, and we are going to add all the values. Okay, so 1 to 10. So this is how reduce function, pass it lambda to it, x plus y, and pass our iterable, our list to it. We get value addition of 1 to 10 numbers as 55. So as you can see, we'll say, okay, it's simple, x plus y, but how does this work? So I will explain it to you. So what does reduce does, from our list, it will take first two values. So index 0 and index 1, 1 and 2, it will consider them x and y first. We'll add it to it, we'll take a 3. Then it will make this 3 as x, take the next value in the list as y, add them. So that's how reduce keeps on working. It keeps on making addition as x and takes the next value and make it as y. So then 6 takes next value as 4, then 10. Then 10 becomes x, next value 5 becomes y, we get 15. 15 plus 6, 21. 21 plus 7, 28. 28 plus 8, 36. 36 plus 9. The next value, we get 45. Now 45 becomes x for our last iteration, 10 becomes y, and we get a value 50y. That's how reduce works on a whole list. It keeps on taking two values at a time and keeps on adding them, and it reduces the whole to a single value, that is addition of whole list 55. Now we'll talk about magic methods. This magic method is also called as special method or dunder methods. There is no specific definition of magic methods, but these methods are implicitly gets called when you make certain calls. So let's say and they have a special syntax, that is double underscore, name of the method, double underscore and end. That's why they are called as dunder methods. So when you pronounce double underscore, it can be shortly pronounced as dunder. So that's why they are also called as dunder methods. So we have defined here integer a equal to 13. Now we have to convert into string. We use usually what? Typecast it to string function, right? You can use same way rep method, which is a magic method. It changes it to string. Python implicitly in background calls this method when you change it to string. So that's how magic method works. If you take a type, it is type string. That's how magic method works in Python. They works implicitly in background. You can call them, some of them, but they are hidden from you generally, and they works in background. So length, you take length of a string. 4. Same way, we have a magic method length which gets called, you get same output. So what Python has done is, they have kept the length and the string same name, the general for it, but in the background it uses these magic methods for doing the functionality, and you can override these methods as well, some of them. So we'll see in terms of iterables, what are they. So in iterables list, we have reverse method. For reversing a list, you print data, you get list printed from 1 to 3, 4. 4, 3, 2, 1. From 1 to 3, 4 list, you have same way an iter method, which is a mapping method. When you iterate over a list, this iter magic method gets called in the background, and the next method is called to get next number in a list. Same way for dictionary, this is our dictionary. It has two keys, age and name. So when you try to access a key in the dictionary, it in background calls magic method get item. So you can directly call a get item and get pass it key, passing we passed a name key, we get John. Same way, when you try to assign a new value, to a key in a dictionary, you can use set item. So now our dictionary has a new key position. There are so much documentation available, but this is the best one I think you can use to check out magic methods. Now we'll check operator overloading. Magic method helps us in overloading operator. First, we'll define class tickets with an default constructor init. Init is also magic method. It has two variables, name and number. So what our scenario here is, so let's say you asked your friends to get some tickets for you. Okay, tickets for any movie or show, whatever you like. So you asked your friends to get some tickets for you. This is a bulk ticket purchasing. So Mary brought 5 tickets. That's one instance. John brought 10 tickets for you. Okay. We'll call another magic method, get attribute name for M1. This is just for an example. Now we'll print both M1 and M2. So what we get? First Mary, that is our get attribute call. Then M1 and M2 both are instances. But we don't, when we call the instances, we don't want to display it like this, an object, information. We want something more informative. So what we do? We override the magic method. When we call a print, it in background calls the magic method underscore str, string underscore. So we are overriding that method. So we define string in our class. So now what we'll do, we'll make the same call, M1 tickets, M2. So first get attribute gets printed, print M1. So as we have overridden this method, what we do, percentage is brought, percentage is tickets. So Mary bought 5 tickets for M1 got printed, John bought 10 tickets. That's what got printed. So now you want to know how many total tickets you got, right? So we are going to print M1 plus M2. Is this going to work? Our plus operator is going to print total tickets, that is 15. Let's see what happens. First Mary gets printed. Mary bought 5 tickets, John bought. Now we expect to print total 15 tickets. We get an error because plus operator doesn't support addition of these two objects. So what we will do now? Now we will overload the operator. So this add method, we write our own add method. So we are overloading the operator. So now, as we are overloading this add method here, Mary bought 5 tickets. Now this is printed from inside the method. So we converted the whole thing into a dictionary and 15 total ticket. So this way you can overload operators. We have overloaded plus operator here. These are, you can same way, there is each and every operator has a method associated to it. You can see from below table. So you can overload these operators by overloading these methods same way for this bitwise operator and these operators. So all these are methods for operator overloading. This is all about lambda, map, filter, reduce, magic methods and operator overloading. Thanks for watching.